All right, guys, welcome back. We're going to be covering our next to last topic in EIGRP. In this particular case, it's going to be EIGRP Stub Routing, the Stub Routing feature. It's not a very long topic, but I am going to show you quite a few things throughout this discussion here. Feel free to ask a question at any time, and then we only have one more lesson for EIGRP. We'll wrap up that topic, and then we'll move into our OSPF topics. So this is actually technically lesson 29 or lesson 30, I believe. It's called the EIGRP Stub Routing lesson. And we're going to talk about in this lesson how to scale EIGRP utilizing what we call stub routing features. Now, traditionally, we always talk about EIGRP and how EIGRP is going to converge and how we can design EIGRP so that it converges much more quickly. And we talked about in the last lesson how we did that with summarization, right? And traditionally, summarization has always been considered something that we would do if we're trying to reduce the overall size of our routing table. But we also talked about the fact that most modern routers today don't really need to worry about the size of the routing table, particularly with the types of domains that we're dealing with on a regular basis. So our purpose in doing route summarization is really to limit the size of our query domain. And stub routing is something that we can do in that regard as well. So we talked about convergence with the EIGRP, specifically sub-second convergence. That's going to be determined based on whether or not we have a successor and a feasible successor. And we talked about the concept of the feasibility condition, meaning that the reported distance of a backup path has to be less than or equal to the feasible distance of the primary path, and so on. But and if you want to go back and review some of the videos on that topic that we recorded earlier, that would be a good thing to do because you're definitely going to need to know that. In the case of this pre-calculated backup route, as long as it passes that feasibility condition check, then we're not really too concerned about the size of our query domain. But what if we can't engineer a feasible successor into a topology? For example, this topology here is not going to have a feasible successor because we don't have a backup path. We essentially here, let me grab a snippet of this topology here. In this particular case, we simply have a stub network. This is what we refer to as a stub network, meaning that there's one way in and one way out of that domain. And if you can imagine behind HQ, there's a whole bunch of routes and a whole bunch of networks because that's our headquarters router. We didn't necessarily simulate that in this particular case, but there's no way to design in to this topology a feasible successor because we only have one way in and one way out. If no backup route exists, in the case of this topology here, for example, there's no backup route, there's no way for us to automatically put into our routing table a secondary path that meets that feasibility condition. So we're going to send a query message. Convergence, when queries go out, is going to be a function, or the convergence time that it takes to converge the topology is going to be a function of the query domain size. And that's really what we're trying to limit in this particular case. Now, there's two ways to limit this problem. In our last lesson, we talked about EIGRP route summarization and the ability to limit the size of the query domain by summarizing routes, meaning that essentially, even though an individual route within the summary goes down, the overall route doesn't change, which means a query is not necessary. But the other is to create something called a stub router. In OSPF, we're going to see a similar function, but in OSPF, we refer to it simply as a stub area or a special area type in OSPF. So our focus in this case is going to be talking about what is an EIGRP stub router, how do we implement this in the configuration, both IPv4 and IPv6, and also in our address family mode of configuration versus our classic process configuration where we have an autonomous system number. So we're going to take a look at that as part of the process. Also, when it comes to the concept of stub routing, we're going to see in our next lesson EIGRP implemented for DMVPN, where we have our hub our DMVPN hub and we have our DMVPN spoke routers, there's no reason to ever query a DMVPN spoke router for routes that we're going to reach behind the hub. So let me draw a diagram that kind of describes this concept. So let's say I've got a dual-homed DMVPN solution. This is hub 1 and this is hub 2. And we've got our individual spoke routers. So we've got S1, S2, S3, and S4. And each of these spoke routers have connections to the hub. You know, for redundancy purposes, maybe even for some sort of load sharing purposes. And then behind these hub routers, we've got our corporate network. Okay? Now, even though it may look like, or it appears as though these spoke routers can act as you know, transit routers to get from, say, hub 2, let me draw a different color here. So to get from hub 2, we could go maybe potentially this way to get over to corp. But we really would never take that path because it's a suboptimal path. It's probably not going to provide us the amount of bandwidth that we need to be able to gain access to those corporate networks. Plus, you know, hub 1 and hub 2 both already have most likely redundant connections to that corporate domain. So we don't really want to use these, as these are what we call non-transit routers, and the only reason they have any kind of redundant connection to the corporate network is purely for that, for redundancy. All right, so let's talk about a scenario in which a corporate network goes down. Let's say, for example, H2 knows about the 10 subnet, 10/8. All right, and that 10/8 network goes down. I may decide that I'm going to go ahead and send a query over to H1, but I definitely do not want to send a query to my spoke routers because my spoke routers should never act as transit routers to reach that 10/8 prefix that's in the corporate network. Okay, and if you keep in mind, these query processes, they're going to occur if I don't have a feasible successor once the successor route goes down, but then those query processes might even actually get propagated back up to the other hub router, and then we have to wait for replies and so on. So the convergence time goes up exponentially, potentially, or we could actually even see a reset of neighbor relationships or whatnot, depending on the code of version or EIGRP we're running. All in all, there's really just no reason to query those routers. S1, S2, S3, S4, and S5 should really never be queried for routes that we lose in the corporate network. Now, if I take my topology, which we're going to be using in this demonstration as an example, it's a similar concept. If this loopback goes down, or if HQ is learning about some other route from other routers in the domain here, if one of those routes goes down, there's no reason to query the branch router for routes that we lose in the HQ side. And remember, we always query all of our neighbors, regardless of whether or not those neighbors could originate that particular route. Okay? So this stub routing feature, this concept of stub routing, it's definitely a good thing to look at when we're doing our DMVPN design, but it's actually applicable anytime you have a situation where you're actually running sorry, lost my connection there for a second. Where you're actually running any kind of spoke router scenario where you only have a stub network one way in and one way out. Not to say that you couldn't apply the stub feature to other places, and we'll talk about maybe some other examples where stub features might exist, but certainly in a DMVPN design, in a stub routing design, you would definitely want to look at it. Remember, EIGRP is a distance vector routing protocol, so we don't have a complete picture of the overall topology. It's a major change from how OSPF works, where we know everything about the topology. So depending on the overall topology size in EIGRP, we could have issues with control plane overutilization from the perspective of these queries being sent out and being received and whatnot. This stub router feature allows us to reduce the load on the control plane. In addition, it also allows us to reduce the overall convergence time in the event that there's some sort of topology change in the overall topology. Okay? So we're going to take a look at this configuration. We're going to look at the configuration from the perspective of EIGRP in classic mode configuration as well as address family mode configuration. We're also going to take a look at the syntax when we're going to, if we were to implement this, say, for example, in IPv6 as well. We try to look at all different aspects to make sure that we have a good understanding, because you never know what they're going to ask you to do on the lab, right? They may say implement EIGRP stub features on this router for IPv6 only, or they might say let's go ahead and implement it in the address family mode. Overall, it's not really going to be much different than what we do in any mode, but we do want to take a look at it and make sure that we understand it. Now, before I get into the actual configuration, I always want to take a look at our topology and make sure we understand what the normal behavior is of our topology so that we can then determine what kind of changes, what changes we're going to make that would affect the overall operation of our domain. Obviously, we're running EIGRP on 3 different routers here, so we're going to take a look at that configuration. Presently, we're running classic mode in each of these routers, but we are going to configure BR1A in named mode a little bit later on. All right, so let's just do a little bit of investigation here. On BR1B, I'm going to do a quick show IP EIGRP interface, so I can see that I'm only running EIGRP on Ethernet 1.1. And if I do a show IP EIGRP topology, I can see that the 17 network, interestingly enough, it is in EIGRP, but it has a feasible distance of infinity. And we'll talk about that in a second. We see this 10.1.0.0.16 network is there. And if we look at our topology, the 10.1.0.0, so that's the one that we're getting from our HQ router. So that network is being learned. So we know we have full convergence at least. The 192.0.0 network is also in EIGRP. That means to say that we are definitely running EIGRP on this loopback as well as being advertised. So both of those routes are being learned on BR1B. And if I go back here, I can see that the 18 subnet is part of EIGRP, but it also has a feasible distance of infinity. We'll talk about what that means in a second here, but it is still part of EIGRP. The routes themselves are still part of EIGRP, which means they're either are interfaces that are going to be running EIGRP, or they're being sent into EIGRP through some method. So we'll talk about that in a second. And the 172.16.1 and the 192.168.116 are 16. So this network and this network. So it looks like we have full convergence. All of those networks are being learned by BR1B, including these guys that have an infinite metric. So let's just investigate. Let's take a look at our show run pipe section EIGRP and see how our config looks. So it actually looks relatively straightforward. It's kind of interesting, actually. We've got a network of 192.168.16. All right. We got a network of 192.168.16, but 17 and 18 are part of EIGRP. That's actually kind of interesting because 17 would be a subnet and 18 would be a subnet. So let me see. Obviously, if I do show IP route, we're going to see 17 and 18 as connected. All right, directly connected and directly connected. Show run interface loopback 0 and show run interface loopback 1. So those are the 2 prefixes that we have on those loopbacks. Let me do one more thing. Show run section. Well, EIGRP would have shown it. Okay. So it is interesting that 16 and 17 are coming in, but they're not coming in because we're running EIGRP on this router. So they must be learned some other way in EIGRP. Now the reason, if I go to show IP EIGRP topology, the reason why they show a metric of infinite is that they're not being advertised into EIGRP from this router. They're connected routes, but they're also being learned from another router. And we'll see why that is in the case here. Just keep in mind that these configurations that are included in this particular topology are not very typical, but we're using these configs to demonstrate a couple of different concepts about stub routing and just taking a look at a bunch of different examples, okay? So I would not necessarily suggest that anything that we're going to see here would be something that you would normally do, but they are definitely configured for demonstration purposes. All right. Let me do a show IP route. Now let me do a show IP EIGRP topology 192.168.17.0 and see if we can see where it's coming from. Yeah, so it's coming from 16.1. All right. So it is actually being advertised from BR1A as a route. The originating router is 192.168.0.1. That's the router ID of BR1A. So somehow these routes are getting into EIGRP. They're just not being locally injected into EIGRP from this router. All right, just something to keep in mind. All right, now let's go look and investigate BR1A's configuration. Show run section EIGRP. We pretty much should see, well, we do have a little bit of a different configuration here. The 172.16.1 subnet is running EIGRP. We can see that is the local LAN, so that makes sense. The 192.168.0 and 192.168.16 are running EIGRP. So that's the 16 and that's the 0, so that makes sense. We're running EIGRP on all three of these interfaces. All right, but we do have a redistribute command on this router as well. And we have a redistribute static, so let me do a show run pipe include IP route. And we can see that we have two static routes that point to 16.2, and that's how these routes are getting into EIGRP. Where we've got static routes configured on BR1A for reachability to the 17 and 18 subnets, and we're redistributing those into EIGRP using a static redistribution. Okay, so BR1B is actually learning about these routes through their directly connected status, as well as through the EIGRP update process. So they would normally show up as DEX routes. All right, they would normally show up as DEX routes, of course they wouldn't show up as DEX routes in BR1B because they're connected routes and those have a lower administrative distance. All right, so let's go ahead and take a look at the configuration on HQ, show run, section router, and we can see it's pretty much a basic EIGRP config. We're running EIGRP on the loopback side as well as the Ethernet side. If I do a show IP route EIGRP, I should see most of those subnets. I certainly see the 00 subnet. Again, that is the loopback interface that sits behind BR1A here. Okay. I'm not going to see 16.1.0 as an EIGRP route because it's connected. Do I see the 16.0 subnet? I do. It's right here, but interestingly enough, it's coming in as a /23. So there must be some summarization that's happening as well on one of the routers. Again, keep in mind, we've kind of thrown together this Frankenstein configuration here just to demonstrate some of these concepts that we're going to be talking about with regard to stub routing. So again, not something that we would normally do. Okay. We're also seeing there's one of the DEX routes. The other DEX routes actually not included here because if I do a show IPsef 192.168.17.1, for example, we can see it's using the 16.0/23 route. So it's actually using the D route over the DEX route, which makes sense because the DEX route has an administrative distance of 170. The D route has an administrative distance of 90. So we're going to be using the 16.0/23 route to reach the 17 subnet. I should be able to ping 192.168.17.1, no problem. But again, I'm going to be using that, that D route, not the DEX route, because of its administrative distance. If they were both D routes, we would definitely use the longest match in this particular case. But because we're doing an AD calculation or comparison first, longest match doesn't come into this scenario. Okay, so let's say, for argument's sake, that we do have a bunch of prefixes behind HQ, and I don't want the HQ router to send a query to BR1A if one of those networks goes down. In fact, let's go ahead and go into our Wireshark capture here. I'm going to do a capture. I'm going to shut down the 10.100/16 subnet, and we're going to see what happens when that route goes down. We should see a query that's going to be generated from the HQ router to the BR1A router or the BR1B router, looking for an alternate path to that particular destination because we don't have a feasible successor. There's no reason why we should ever query BR1B for that network because it doesn't exist anywhere else except for behind HQ, but that's the whole point of this conversation. All right, so let's go ahead and filter out not selected, that, and let's get rid of our CDP, and let's get rid of apply filter and not selected. So we're just seeing our EIGRP messages. So there's our hellos going back and forth. If I go into my HQ router, config T interface loopback 0 and shut it down, I should see in my Wireshark capture a query should be sent. You know what? In this particular case, let me see here. I should have seen that query go through. Let's do this. Let me bring it back up. Show IP interface brief. Let's make sure I'm shutting down the right one. Okay. So, and let me go into, I'm going to do this two different ways. I'm going to go into BR1A as well, and I'm just going to do a quick debug. Actually, I'll do the debug on HQ. So debug EIGRP packet, and I'm going to do query and reply on this guy, and I'm going to do the same thing on BR1A, debug EIGRP packet, query and reply. All right, so now let's go ahead and shut down that interface, and I should see a query sent. Yep, there we go. Not sure why I didn't see it in Wireshark, but I definitely saw the query is sent. I ran into this last time when I applied some filters. It ended up filtering out a lot more stuff than I wanted it to. So let's see if we take off the filters here, and let's just apply a filter based on packet type. Let's go into here and let's do apply filter as selected. Okay, so there's the query. All right, now if I open up this query, what I should see is that query is originating from the HQ router, which is 1.1. In this case, that is true. It's coming from 1.1. If I can get it here, hold on. Let's get this guy. All right. So the packet is originating from 1.1. And in this packet, we're saying, hey, this is the route that I lost. Could you please tell me if you have any information about this particular route? This is the router ID. It was originating the route. That's why the next top address is quad 0, because it was originating the route. But frankly, there's no reason that I should ever send a query to that router. Now let me see if I can see a corresponding reply. This is the reply. This reply is coming from BR1A. The source is 1.2, the destination is 1.1, and this router is essentially saying, you know what? I don't have a route to that destination. All right. In fact, if you look at the metric, the delay is infinity. So it's basically saying, in this particular case, I don't have a route. Don't come to me to get to that particular destination. But this is a process that didn't really need to happen because there's no reason why HQ should ever query BR1A for routes that it loses behind HQ. Okay? And that's where the stub routing feature comes in. It's a really simple configuration. We're going to go, let's do a no shut on this loopback real quick. We're going to go into our routing process, and we are going to, we're running EIGRP process ID 1. Let me verify that. Show IP protocols, include EIGRP. Yeah, EIGRP 1. All right, so we're going to go into process or autonomous system number 1, and we're just going to simply execute the command EIGRP Stub. That is literally the command that's necessary to configure this feature. All right. Now what's happening is, and you notice that the adjacency did reset. We didn't do a soft reset on the adjacency here. We did a hard reset. But essentially what's happening now, if I go back to my Wireshark capture, I can see that hello packets are coming from 1.2, but inside the hello packet, we are going to identify ourselves as a stub router. And if I go all the way down to here, we see a new section or new TLV has been added to the router saying, I am a stub router. Okay? Now, obviously, the point of this conversation is to learn what that means. And there's a couple of different meanings. But let me talk about the first meaning. I'll talk about these flags in a little bit. And I'm not sure why the redistributed flag is set. That's something that I saw in the last time I did this lesson. It seems to be erroneously marked in Wireshark for some reason. But I don't want to talk about the flags just yet. The very first thing, there's two functions of stub routing in EIGRP. The first function of stub routing is to inform my neighbors, don't query me. Doesn't matter what it's for. I am not going to be able to provide you any information about alternate paths to any destination, so please do not send me queries if you lose a route. All right? And if I go to HQ, in fact, and I do a show IP EIGRP neighbor detail, we can actually see that this particular neighbor is advertising itself as a stub. We'll talk about what the connected in summary means in a minute, but it also says here, I'm suppressing queries to this particular neighbor. So if I come in here and I do a shut on the loopback, I am not going to send a query to that particular peer. I received a query because the stub router lost the 10 network. So I can see I received a query from 1.2 saying, I lost my route. Can you please tell me if there's another route? And I send a reply, of course, saying, no, there isn't another route. But I didn't send the query in this particular case. If we scroll up here, we can see that we in-queued a query out of Ethernet 1.0. We sent the query to the peer, and we got a reply from the peer, which is 172.16.1.2. So because this particular peer is advertising itself as a stub router, that means the HQ router will never send a query to this router for any information. We also configured this function under the process, under the routing process. We didn't do this on a per interface basis. So I'm sending hello packets with the stub flag set to both of my peers. So consequently, BR1B is also not going to send any queries to BR1A in this particular case. It's a really, really simple concept. The stub flag gets set. We identify ourselves as a stub router. And then there's a secondary component to this. All right? And how we decide to implement this secondary component really depends on our overall topology. All right, so let me explain what I mean. You'll notice that when I go to HQ and I do a show IP EIGRP neighbor detail, we're suppressing queries to this peer. The stub the peer is advertising itself as a stub router, and then in parentheses here we see this thing called connected and summary. All right. Now let's talk about what that means from the perspective of EIGRP stub configurations. Not only does the stub configuration limit the queries that go to that peer, so we're not going to send any queries, but it also allows us to limit what this branch router advertises to the upstream neighbors, both neighbors in this particular case. Okay? How you decide to implement this particular feature really depends on what your overall objective is inside of EIGRP. In our case, we're doing connected and summary. Now, what this means, by the way, that's the default. When you configure EIGRP stub in any mode, we're going to do connected and summary by default. What this means is that this router is now only going to advertise to its peers EIGRP routes that are connected and EIGRP routes that are summaries. And we actually do have a summary configured. Show run pipe includes summary. We actually have a summary configured on this router pointing to HQ. So now if I go to my HQ, you will notice, do show IP route EIGRP, that we've actually lost a route. We've got the 00, which is the loopback that's connected to BR1A. We've got the summary, which is being originated by BR1A, but we lost the 17 and 18 routes. Now, obviously 17 is going to be included. If I do a show IPsef, 192.168.17.1, we can see that the 17 route is included in the summary. But if I did an 18.1, there would be no route for that particular destination. We'd be trying to match it to a default route, but the default route points to a different direction and it's not going to route. Okay, I don't even know if we have. Let me see if we even have a default route configured. Yeah, so we don't even have a default route configured in this particular case. So that's why it's indicating that it would have to match a default route, but we don't have a default route, so it's going to drop the packet. So what does that mean from the perspective of our topology? Well, it means that this 18 subnet is no longer going to be reachable because it's not part of the summary and it's not connected to BR1A. Does that make sense so far? What are my other choices when it comes to configuring this stub configuration? Let's go back to BR1A and take a look. Config T, router EIGRP1, EIGRP stub, question mark. I can send connected routes only, right? I can send nothing and only receive routes. I can send redistributed routes. These would be routes that are redistributed in the EIGRP, which, by the way, could be any type of redistribution. I can send static routes, right? I can send static routes. This would also be routes that are redistributed into EIGRP, but only with the redistribute static command. I can send summary routes. And we already said if we do just a carriage return here, it's going to include connected and summary by default. So if I just do connected in this case, all right, I reset the neighbor relationship. If I go back to HQ, now the summary should be gone. And only, let me do EIGRP in this case. Only the connected routes, which is 00 and 16.0, are now being advertised by the branch router. You might say, well, why would I do that? I still want HQ to be able to reach those other destinations. But in reality, it just depends. It depends on your scenario. Maybe you don't want HQ to reach those destinations, or maybe you're using some default routing on the HQ to get to those destinations. The overall goal here is to reduce the size of, or the load on the routers, and then also to reduce the scope of queries that are being sent back and forth. Okay? So we've got connected there. Let's see if we just do summary. All right, now obviously in HQ, well, maybe not obvious, but I should now only see the /23. If I do redistributed, then I should only see the 2 static routes. So I'm not changing the fact that I'm not going to be queried, because stub is stub. No matter what type of route you're advertising, the stub routing feature is going to indicate that you're never supposed to be queried. All right, but you can see how it affects what I'm advertising to the peer based on the different stub configurations that I've applied. If I did receive only, for example, then I would suspect that on HQ I'm not going to receive any routes. So I might just put in a static route here on HQ to point to BR1A. I still want to have the adjacency because I still want to be able to maintain. Remember, well, I didn't really say this before, but it's really important. We're not affecting at all, in this particular case, stub features do not affect what comes from HQ to the branch. So HQ will still query the branch if it loses routes. Okay, HQ is still going to send queries to the branch. We're not sending queries to the branch. Branch would send queries to HQ though, because HQ is not configured as a stub. And also, all of the prefixes that HQ is aware of will still be sent through EIGRP. All right, so all those different prefixes that might exist behind here, they're going to get routed through EIGRP to the branch router. So we're not suppressing what the branch is learning from HQ. We're changing what HQ is going to learn from the branch, if that makes sense. Okay? So we have lots and lots of different options. Like I said, the option that you choose really depends on what your overall objective is. So on the lab, they might say, I only want to send in receive-only routes. I only want to send in summary routes and redistributed routes. So you would just do a summary redistributed, okay? Or I only want to send in summary routes and any route being redistributed into EIGRP statically. All right, so now we'll see the 23 route here. Do show IP route EIGRP, and we should also see the 18 route, because remember 17 is included in the summary as a D route, not a DEX route. So we can manipulate what gets sent from the branch router by simply putting in the stub configuration. Okay? Now there is one other option here, and that other option that we see here is something called a leak map. Leak maps work the same way that we've seen them before in some of our other discussions. It allows us to apply a set of routes, or allows a set of routes to get leaked out of EIGRP. Let's do leaky stuff. Okay, we don't have that configured yet, so nothing is going to be leaked out. But there is something I want to point out here. When you apply a leak map to your stub feature, if I do a show IP EIGRP neighbor detail, we can see that there is a leak map applied to the stub feature, but automatically connected and summary are going to be included as well. You can't get rid of that. You can't say, for example, apply a leak map and then do static only, or apply a leak map and do redistributed. So as soon as I apply a leak map, the connected and summary routes are automatically going to be sent as well. Okay? Now we're not leaking anything out at this point. Let's go ahead and take a look at our routing table, show IP route EIGRP. All right, so I've got 192.168.0.0, which is connected, and then there's my summary. 16 is going to include 16.0/24 and 17.0/24. So what's not being sent out is the 18 network. All right, which makes sense. It's redistributed statically, but let's say that I did want that 18 subnet to be leaked out. All right. Let's do something else as part of this process, because we're just about wrapped up here with our discussion, but there's a couple of other things that I want to show you guys real quick. So let's do a show run pipe section EIGRP. And what I'm going to do is I'm going to go ahead and I'm going to blow away the EIGRP configuration. No router EIGRP. And I believe that should take care of the summary as well. Let me see. I may have to go in and drop off that summary. Nope, it took care of the summary as well. We're not running EIGRP. There's no reason to have an EIGRP summary route on the interface. And I'm going to go ahead and set up EIGRP address family configuration, or what we call named mode, router EIGRP, CCIE. And we're going to go into address family IPv4 unicast and autonomous system number 1. And we're going to go ahead and add our network statements. So I'm just going to add the network statements that are part of, oops, got double networks there, that were part of the classic configuration. So the only thing I'm missing in this particular case is the summary, and I'm also missing redistribute static. You'll notice here that redistribute is not an option. All right, that is going to be part of, because it affects the overall routing process, that's going to be part of our topology base. Let me go back into the address family. Sorry about that. That's going to be part of our topology base. We do redistribute static here. Remember, topology literally means the EIGRP topology database. Well, I'm affecting what goes into the EIGRP topology database by redistributing routes into that database. So when you're trying to figure out where these commands apply, you can either use your question mark, because that's perfectly legal on the lab exam, or you can kind of think through the process and identify, oh, I'm manipulating the routes that are going into EIGRP, so I'm going to go ahead and that's what's going to go into the EIGRP topology, show IP EIGRP topology, so that's going to be my topology base. All right. Now, if you look here, stub, if I could type, is not an option under topology base. Stub routing is a feature that is configured under the routing process, right? The address family routing process. So address family, IPv4, forgot my EIGRP stub, but we'll get in there. Unicast, autonomous system number 1, EIGRP stub. So we have that option here. All right, I'm going to go ahead and do just a leak map, leaky stuff. All right, and we should see the neighbor adjacency reset. And if I go back to HQ, I should see in the case of the neighbor, I have a leak map applied. Connected summary is also being sent in. If I do a show run section EIGRP, I can see the entire address family configuration. Oh, I haven't put in my summary. I guess I should do that. Now, summaries are done under the interface. So in named configuration, we have to go into AF interface, and we're going to apply that summary to Ethernet 1.0. All right, so Ethernet 1.0, summary address. We don't need the EIGRP because we're in address family mode, 192.168, 16.0/23. All right, so I should now see that summary route in this router. So we're back to where we were before. Okay, love the address family configuration because everything is nice and concise in the parser. It's actually very clean. And we don't have to worry about stuff being applied to the interface and stuff being applied to the routing process and so on. Everything is nice and clean under the address family configuration. Okay? So, my goal in this particular case is to leak out the 18 route as an exception to the rule, because it's not a connected route. It's not a summary route. It's actually a route that's being done through redistribution. So what I have to do is a couple of things I can do. I can either create an access list or I can create a prefix list. We typically deal with prefix lists, prefix, not reflexive, leak out. And we're going to go ahead and permit 192.168.18.0. And if I don't use an operator, it's going to match the route exactly. So I want to leak out network 18. Let's assume, I mean, that's going to end up being all of our subnets, but let's assume in this particular case, I've got 19, 20, 21, 22, or whatever, however many subnets here, and I'm choosing to leak out only 18, okay? 17 would already be included because of the summary. We're actually going to create a route map, and we're going to give the route map the name, the same name. Well, we could do a permit 10. It would automatically apply that anyway. Match IP address. Make sure you put prefix list, otherwise it's going to assume access list. And we're going to put in the prefix list that we created. All right. So show run pipe section EIGRP pipe route map pipe prefix. And we can see the entire configuration. Here's the prefix list that we're matching the 192.168.18 subnet. Here is the route map that we're permitting that route to be leaked out essentially because it's being applied to the leak map statement. And this is the reference to the prefix list. And then under our EIGRP stub configuration, we've got a leak map applied with leaky stuff. Leaky stuff is the name of our route map. So if I go to my HQ router, I should see now that 18 route as well. I'm not seeing it. Let me make sure that I did this correctly. Show IP interface brief. Show IP route. Oops. It's definitely in there as a /24. So let's see what we did wrong here in our configuration. I've got EIGRP stub connected. Leak map, leaky stuff. Prefix list, leak 18 out. Permit 192.168.18.0/24, which should be an exact match. Let me do this. Show IP route 192.168.18.0. All right. So it is in as a static route with a /24 prefix. Show IP EIGRP topology 192.168.18.0. And it's definitely in EIGRP as a /24 as well. We can see that right here. It has a valid metric. So why isn't it being leaked out? Route map leaky stuff, permit 10. Let me do this. Let me go back to router EIGRP CCIE and address family IPv4 unicast autonomous system number 1, no EIGRP stub. I just want to make sure that the route's going to come into HQ. All right, so it is definitely coming into HQ. That's always a good thing too on the lab, guys, by the way. If you're having issues with a particular feature that you're trying to implement, back out of the feature and make sure everything is working without any enhancements or any enhanced configuration before you start going down the path of troubleshooting the feature itself. That way you know that it's not maybe an underlying problem related to something else other than what you're actually trying to configure, if that makes sense. So it's always kind of, if you have the time, it's always kind of a good idea to take that route, okay? No pun intended. So let me go ahead and reapply. Oops, I want to stay in address family mode. Let's do an EIGRP stub, and let's do leak map, and let me get the name of the route map here. Leaky stuff, and see what we see here. Interesting. So I'm not exactly sure why that particular route's not being leaked out. But what I'm going to go ahead and do is I'm going to create a prefix list saying no-1. Let's just do no1. That will make it too complicated. And I'm going to deny the 1.0/24. I created another prefix on the BR1A, do show IP interface brief. We don't have any stub configuration applied, so we're getting all of these routes. You can use a leak map to leak routes out just as easily as you can use a leak map to filter routes that are being leaked out. So in this particular case, we're trying to filter out this 1.0/24. So actually, I should do this. There's a couple ways we can do it. Let's do it this way. And let's permit this guy in the prefix list so we can match the route. And then in the route map, oops, permit, not prefix. And then when we create a route map, my map, deny 10, match IP address. In this case, we did a prefix list, no1. And then we're going to do a route map, my map, permit 20. That'll be our kind of implicit or explicit permit for the remainder of the routes. So what I should see, show run pipe section. I also converted this guy back to classic mode just to see if it was an issue with named mode versus classic. It wasn't. We still couldn't get that route to leak out. It's going to be an interesting thing. I may have to do a little research on this because this is kind of one of those quirky little things that there's probably a reason. It could be an order of operations or how the local router is using the route. That's why I wanted to go to a connected route. But technically speaking, it should really be no different. A connected route is, as long as it's part of EIGRP, is still considered an EIGRP route, just like a static route that's redistributed into EIGRP. So if I do EIGRP stub, I should still see the one subnet, right? Because it's a connected route. And when you do EIGRP stub, you're doing connected and summary. So now if I apply the leak map, and we called it my map to the process, hopefully, in this case, the one subnet goes away. So something is definitely not working here. And I know that this is the correct configuration. I'm going to try one more thing, and then I'm going to chalk it up to something strange with this code. I'm not sure why it's not working. It's a very, very simple configuration. So show run pipe section router. All right. I'll go ahead and leave the leak map applied, and I'm going to do IP access -list standard try again. In this case, I'm going to do a deny of 192.168.1.0, 0.0.0.255, and a permit any. So I'm going to try this with an access list now. And I'm then going to go into route map, my map, deny 10, match IP address, try again. Oops. Do show run section route map. I've got to take out the reference to the prefix list first. So let's get rid of that, and let's do a match IP address, try again. Show run pipe section route map, access -list, EIGRP. All right. So here's the access list. Try again. We're denying the 10 subnet /24. We're permitting everything else. We've got EIGRP Stub connected summary, which it added, by the way. I didn't put that in there, but that's by default. Even if you apply a leak map, it's going to include connected and summary. My map, route map, my map. It denies the leaking of whatever's permitted by the access list, and then it permits everything else to be leaked. So let's see if, yeah, it's not working. I'm not sure why. This is an interesting thing because I did this exact same demonstration the first time around. Everything seemed to work just fine. So I'm not exactly sure why it's not working. And it's kind of driving me a little bit batty here. Let me do one more thing. Keep saying that, but and I just want to see what we're referencing here. Leak map name, which should be a route map. Because there's no option in global config to create a leak map. There's no such thing as creating an actual physical leak map. So I'm not sure why it's not working. I'm going to have to do a little bit of research on this and maybe figure it out. But the basic concept of the leak map configuration is that you would create either a prefix list or an access list that's going to permit typically what you want to be allowed out, besides whatever the stub feature is allowing, which is connected in summary. And anything that's going to be permitted or matched by the route map would also be leaked out to the other peers based on the stub configuration. So I'm just really not sure why it's not working. Show IP EIGRP neighbor detail connected summary leak map. I'm sure I wouldn't really be able to see anything in. Well, I might be able to see something in the capture. I should see an update come out if I go into interface Ethernet 1.0 and do a shut and a no shut. And I'm wondering if the update would include some of that routing information. Not seeing it here. Maybe it's going to be in this packet here. Yeah. So it's interesting that it's being advertised. It's not being filtered. Do I see any stub? Well, this is an update, so that's okay. But it's definitely advertising the route. It's definitely advertising the route. Make sure that we're advertising ourselves with a stub flag. Now I did notice something here, and this actually could be, well, this is interesting. Leak map not set. Leak map not set. Well, we're seeing some really strange things here. See where it says connected, summary, redistributed, receive only? You would never see that, of course. You can't combine receive only with other combinations. So there's definitely something going on with this particular code. It's definitely not cooperating. We're seeing some very strange things. So clearly we do have a leak map set. Show run section EIGRP. So I have a feeling that there's some issues with the code in this particular case. That's what I'm going to chalk it up to. All right. Hopefully you guys at least got the general understanding or concept of applying a leak map to the process. Okay. Any questions? That's pretty much it for our discussion this time. Do you guys have any questions?
Nope, seems good.
Okay.
No, I think I'm good.
Yeah, it's just really strange. We're seeing those different flags set. I'm not sure if something definitely going on with this router here. I mean, it is advertising itself as a stub router, but you would never see those 4 flags set together. Connected summary, redistributed, and receive only. Very, very strange. Very strange. All right, well, we'll go ahead and wrap it up. We'll see you guys in the next lesson.